waiting for over 100 years, we have finally seen the first photograph of a black hole. But some people don't understand just how amazing this feat is. Sure, the photo itself may not have the best quality, but for anyone complaining about the quality of the picture, take a look at this. This is the first colored image of Saturn ever taken. It was taken by the Cassini-Huygens spacecraft in 2002. That's not even 20 years ago. Compare that to this image of Saturn taken by the Cassini spacecraft in 2016. The improvement in just 14 years is incredible. When you also take into consideration that Saturn is only 1.2 billion kilometers away, while the distance to the black hole is over 53 million light years, a little blurriness doesn't seem too bad. If you were near that black hole taking a photo of the Earth, you'd see an Earth in the Eocene era, still populated by the dinosaurs. Even with the blurriness, this photograph of a black hole took the world by storm, and for good reason. We've been waiting to see this for hundreds of years. Let's take a look at the history of black holes and see just how long this anticipation has been building. As you most likely know, black holes are massive structures whose gravitational pull is too strong for even light to escape. They're often described as gravity wells, and while Einstein is often linked to black holes for his theory of general relativity, the history of black holes starts with the father of all physics himself, Isaac Newton. In 1687, Newton gave the first description of gravity in his publication that would change the world, Principia Mathematica. Nearly 100 years later, a clergyman by the name of John Michell proposed the idea that there could exist a structure that would be massive enough that not even light would be able to escape its gravitational pull. In 1796, the famous French scientist Pierre-Simon Laplace made an important prediction about the nature of black holes. He suggested that because even the speed of light was slower than the escape velocity of a black hole, the massive objects would be invisible. Laplace was, of course, exactly right, and that's one reason the picture the world saw is so incredible. In 1915, Albert Einstein changed physics forever by publishing his theory of general relativity. In this theory, he explained spacetime curvature and gave a mathematical description of a black hole. Despite his work supporting the belief in their existence, Einstein himself had his doubts. It would certainly be interesting to see his reaction to the picture. And in 1964, John Wheeler gave these structures the name we use today. This is a good thing because something tells me first photograph of spacetime singularity wouldn't be such a good headline. Of course, no list of black hole history would be complete without Stephen Hawking. His work greatly expanded our understanding of these mysterious structures, predicting the nature of their deaths through Hawking radiation. His famous equation is engraved on his tombstone. So, this photograph isn't just a smudgy picture of some weird space stuff. It's the realization of over 300 years of scientific work. Scientists from all over the world stood on the shoulders of giants to get a better view of the stars, and this image is the result of that collaborative work.